In this lecture, we are going to write a program to transmit and store an array of data on a particular location in an I2C based EEPROM. Right? So in the previous lecture, we did the same thing for a single byte. So we will basically transmit the data from our microcontroller and store it in our EEPROM, and we will read the same data and store it back in a variable and then display it on our hyperterminal screen, and that we will do using UART, the displaying on the hyperterminal the data that we read, that we will display using UART. Okay, so for that we need to make some new functions for writing and reading the data uh, as an array. Okay, so just open your Eclipse IDE again. Okay, so this is our previous program, and in this program the drivers we have to update them. So you can update in this same drivers also, or you can make a new copy. So I will just make a new copy. I will just copy it and I'll paste it over here, and we will do some modifications in this only. So first of all, change the name. Okay, so just add array after the name, and as this is an array, this is not a byte data anymore. Okay, okay, and so the size of the array won't be fixed, hence we need to put it as a pointer, and because of that only we will have to provide the length of the array as well. So length, so we are passing three arguments. Now what needs to be changed? So now this length won't be fixed, right? So we will have to make another buffer. So I'll just make another buffer by the name tx underscore buff, and we'll make it of 17 elements, right? And what we are going to do with this? So we will make a for loop first of all. So for I will have to add another variable, define another variable for loop. So for I equals to 0 and I less than length and I increment. Okay, so this is my for loop, and in this for loop what I will do is I will store the data, array of data, into this buffer, and this buffer we will transmit on our I2C bus. Okay, so just copy this tx buffer and paste it over here, and just put I, and in this tx buffer what we are going to put is we are going to put our array data. So just copy this whole thing. Okay, so that's it. So this data will be transferred or saved into this tx buffer, and this buffer we have to put it over here in the place of byte data, tx underscore buff, and the one here beside this is the was the length of the byte in the previous program. So here the length won't be fixed, so the argument needs to be passed over here, right? So this is all about this program. There are no more modifications required. So using this program you can easily transmit and write array of data into our EEPROM. Now the next thing is this function I2C underscore EEPROM underscore read. So reading for array is also slightly different. Okay, so just copy this and make a new copy and give it a name read underscore array, and here also you will have to pass three arguments, the same three that we passed in here. Okay, so I will just copy it and I will replace it with the previous argument. Previously we were only sending the address, right? So here along with address we are putting the array data and the length as well. Okay, so in the here I will give the name buff data buffer, as we are storing something into it, right? And this buff data, just copy it and replace it by r byte. Sorry, just copy it and replace it by r byte in both the functions, in this one as well as this one. And this length, you replace it by 1. This was the size of the byte. Okay, so here the size won't be fixed, so it will be whatever we will provide in the length, right? So this is it, and our both the functions are ready. So just copy these functions and declare them into your header file so that we can use them in our main function, right? Again, copy this also. Okay, now just save it and go to your main program. Now in the main program, what we will do is we will update this program only. So first of all, this won't be needed, so I will just remove it. Okay, and this also. So first of all, what do we need to do? So we want to transmit an array of data, right? So first of all, what is the data that we need to put into our transmission array? Okay, so first of all, we need to define two arrays, one for transmitting and one for receiving. So I will just define it over here. That is data underscore tx. Uh, this array will be of, let us keep 16. Okay, this is for transmitting the data, and similarly data underscore rx, it is for receiving the data. Correct. Now let us make a for loop. So for the for loop also, I will need one variable I. So in this for loop, what we are going to do is we are going to store the numbers 0 to 15 in each byte of our transmission array. Okay, so I'll just copy it, and in this for loop I will put and I equals to 0 till I less than size of our data underscore tx array. Okay, so it will take the size of this array, that is 16. Okay, and I increment, and in this array what we are going to do is we are going to put each number. So we have to put it like this, data underscore tx, and inside this I equals to I. So the number from 0 to 15 will be stored into our array here. Yeah, now the your transmitter array is filled with data. Now the data is ready to be transmitted. So for that, our function we will use, that is this one, EPROM write array. Okay, so just copy this and paste it in your main file. So first argument, you have to transmit your EPROM address. So let us take the EPROM address as, for example, 0x150 or 250. Okay, so this is our starting address of the data. The next argument is the array data. So here we will pass our array, transmitter array, and in the end the length. So length also we will give size of transmitter array, that is data underscore tx. Okay, so this is our function. So using this function, the data, all these 16 bytes will be written onto this location 0x250. Right now, once the data is transmitted and stored into the EEPROM, now we have to read that same data. So for reading the same data, the function is this one, that is I2C-EPROM read array. Okay, so I will copy it and paste it over here. So all these parameters will be the same as above, right? So only one thing will change, and that is our buffer, that is receiving array, that is data underscore rx. Okay, now we have both stored the data and we have received the data also, and we have stored all the received data into this data underscore rx. Now what we need to do is we need to uh, use this data to display on our hyperterminal screen. Okay, so this data needs to be displayed on the hyperterminal screen, and we are going to do that using UART. So currently this data is in the form of integers, okay, and our hyperterminal can only display ASCII characters. So now what do we need to do is we need to convert this data from integer to array. So for that I have used a function, ready-made function, that is this one, I2A. So you can directly use this function for converting from integer to ASCII. This I2A means integer to ASCII, and it takes two arguments. That is, the first one is the data which needs to be converted. Suppose that this is an integer, right? So the first parameter will be the integer data, and the second will be a variable in which the converted data will be stored. Correct. So this data is defined here, and I've already declared this data on the top here. Okay. So you will have to also declare this data on the top. So for the time being, just copy this and paste it over here. So this also we need to do in a for loop. Okay, so our UART cannot directly display the whole array, so it will display one by one. So for that we will have to use for loop again. So here, for I equals to 0 and I less than size of data underscore rx, okay, and I increment. So all the operations we will do inside this for loop only. So the first thing that we are doing is copying this function, and in here the first thing that will go is data underscore rx and the appropriate byte, so I, and we will store that in a variable, so that variable needs to be defined here. So now we are going to display 0 to 15, right? So 0 to 9 it will take a single variable, but from 10 to 15 it will become 2 bytes. That is, 0 to 9 it will be 1 byte, and from 10 to 15 it will be 2 byte, right? So we will define an array of 2 bytes. That is, I will give it a name, converted value, and we will provide it as the size of 2, right? So just I will use this over here. So I will just copy it. Right now the appropriate byte is converted into ASCII, and it is stored into this variable converted value. Now what will we do? Now you can display this data on the hyperterminal using in two types. So you can display this data in a single line by providing spaces in between, or you can display each byte on a single line. Okay, so we will just put space in between them, right? So I will use the function for UART. So for that, just go to uart.h haul file, and in that you will find the function haul underscore UART underscore transmit IT. This is the interrupt function for UART. So I will copy this and paste it over here, and let us set the first argument, that is the handler, and we will use UART4. Okay, then the data. Now what is the data? So it is our converted value, right? So just copy this converted value and paste it. Then the size of the converted value. So the size of the this converted value is 2, right? Okay, now let us provide some delay, that is haul underscore delay 500, and again copy this function, and instead of this converted value put empty space here in inverted commas. Okay, so the data will be displayed after space. So just copy this delay and paste it. Okay, so your whole function is complete now, right? So this program, just save this program and build it. So it is giving us some errors. So it is saying that data underscore rx is undeclared. Okay, so how is it undeclared? So basically we forgot to put the comma here. Okay, so just save and build again. Now again it is showing some errors. Now this time it is in txbuff. It is undeclared. So yes, we are using uh, tx underscore buff over here. So the name is incorrect. So again save it and build it. Okay, now the program is built successfully. So these kind of small mistakes happen while we write the program, but the main thing is you need to understand what the errors are and you should be able to troubleshoot them, right? Okay, so now the program is complete, so you can open your flashing tool, close your old X file, open the new one. Okay, so I will open this and inside debug you will find your X file. So just connect your board, then program and verify and disconnect. The connections of our board are similar to the previous one, right? Now open your Terraterm, that is your hyperterminal application. So inside that, first select your COM port. In my PC it is COM3, and the baud rate you don't need to change because we have all set the baud rate to 9600, and Terraterm by default sets 9600. So I will just press reset button and it will show all the numbers from 0 all the way to 15, okay, on this Terraterm screen. So I'm pressing the reset button now. So you can see that the numbers from 0 to 15 are being displayed on the Terraterm screen with the delay of 500 milliseconds, right? So in this way you write the data on your EEPROM and read the data and display it on the UART terminal.